Good day, everyone. Welcome to our discussion. This is our last example class on our topic rectilinear motion, review of rectilinear motion. Okay, so this is the last problem. Freighter is moving at a speed of 8 knots. So, what is freighter class? So, when we talk about knots, no, this is the units of uh, measurement of the speed, so it means something that is moving in the water. So if you don't know what is freighter, okay, so that's how to imagine. You guys just imagine a ship. So a freighter is moving at a speed of 8 knots when its engine are suddenly stopped. So if it takes 10 minutes for the freighter to reduce its speed to 4 knots, determine the plot, the distance s in nautical miles moved by the ship, and its speed v in knots as functions of the time t during this interval. The deceleration of the ship is proportional to the square of its speed, so that a equal to negative k v squared. Alright, so here's the solution. So the speeds and the time are given in this problem. Okay, so we have 10 minutes. We have here 8 knots initially and reduced to the speed of 4 knots. So these are speeds. Okay, so the speeds and the time are given, so we may substitute the expression for acceleration directly to the basic definition of acceleration, equal to the derivative of the velocity with respect to time, or a equal to dv over dt, and then integrate. Thus we get this one. Okay, so similar thing, no, as what we have discussed in the other video. So you start with this acceleration equal to the derivative of the velocity with respect to time, dv over dt. Okay, and then manipulate it. Then using what's given here, we have the acceleration that is minus kv squared. You substitute it here, then cross multiply, then integrate, and we get this one. All right. So for your practice, you just do it yourself. No? If you don't know how to do it, then just let me know. I can show you the solution for this one. All right. So after integrating and substituting the limit, so we got here 1 over, so negative 1 over v. Okay. So because we used here, so what will happen here is you raise above. Okay. So bring this above. So you have a integral of v to the power minus 2 dv. Then you integrate, so we have v minus 2 plus 1 over 2 minus 2 plus 1. So you'll get this negative 1 over v. Okay, when you substitute the limit, the upper limit is v, then plus substituting the lower limit, that is 8. So we have this 1 over 8 equal to minus kt. So from here you find the LCD and then you solve for v. So v is equal to 8 divided by 1 plus 8 times kt. Alright, so class, this is just algebra. So I hope you have no problem in solving this equation. So this is just algebra. Here you do integral calculus, and of course together with your knowledge of differential calculus. And then here you just solve for v using your skills in algebra. Now we substitute the end limits of v equal to 4 knots and t equal to 10 over 60 equal to 1 over 6 hours, and we get this. Okay, after substitution. So this is our v, right? Substituting the v here, which is 4. Now we'll be able to solve for k here, 3/4 per mile. And substituting this value to this equation here for v, this equation for v, and you'll get v equal to 8 over 1 plus 60. So substituting the value for t here using this one, then you'll get the value for v. So the speed is plotted against the time as shown. Okay, so here this is the illustration here. So speed is plotted against the time as shown. So using this, so we can plot this one, t equal to 0, at t equal to 1, 2, 3, 4, and so on and so forth. So you will get this graph, this one. All right. Now the distance is obtained by substituting the expression for v. All right, the expression for v into the definition of v equal to ds divided or ds over dt and integrating. So again, we go back to this one, substitute the values of v, and then you integrate. So we'll have this result. So 8 over 1 plus 60 equal to ds over dt. So this is our v. All right. So we use this one, ds over dt. Okay, ds over dt. So this is our ds over dt here. Okay, and then after that you integrate both sides. So integrating both sides with the limit for the left side, limit is from 0 to t. On the other side, the limit is from 0 to 8. So after substitution, after integration and substituting the limits, so we get here s equal to 4 over 3 ln of 1 plus 6 times t. Now the distance s is also plotted against the time as shown in this illustration here. Okay, so and we see that the ship has moved through a distance s equal to 4 over 3 ln of 1 plus 6 over 6 after 10 minutes class. So the 10 minutes here is, that is 1/6 hour. So we convert 10 minutes here in terms of hours. So we got this 1 over 6 hour. So this is the value that we substituted here. So equal to, so 6 over 6 equal to 1, 1 plus 1 is 2. So we have the 4 over 3 ln of 2, which is equal to 0.924 miles. This is a nautical mile. That is during 10 minutes. All right, and this is plotted in this curve. Okay, so this is our last example, and hope to see you again in our next video when we discuss curvilinear motion. All right, thank you very much class, and see you again next time in our next video. Bye.